We have covered tropical cyclones pretty much. Okay? So let's revise everything we've done up to this stage. So very important, the origin or how a tropical cyclone forms, the characteristics, how it's named, the different names, the different stages, and how it goes through development, how it decays, all of that lovely stuff. So pretty much by the end of today, all of these are the things you should know and understand. Okay? Especially weather patterns, the factors, the stages, the effects, how also to manage the effects, and how to introduce like early warning systems and the like. Okay? All of this is important to know. Okay, so in terms of where it starts, where exactly do they start?
Back to this.
Okay, why specifically there? And Coriolis force and what? Latent heat. Nah. Latent heat. What is latent heat? What is latent heat?
So isn't it the starting of sunlight from the sun to the ocean?
It's heat released during condensation, which contributes to the instability of air in the ocean.
There we go. So it's condensation released. Okay? It's condensation that is released, causing latent heat. And what is latent heat needed for?
Formation.
And to feed what?
The air.
To feed what? Oh, guys. Tropical cyclones need latent heat to feed it its energy to form and to actually develop, right? Okay. So remember, it forms these cloud walls. Okay, that can stretch for like 200 to 2,000 kilometers, nah? In thickness and breadth, right? So for that to form as well, you need condensation, you need evaporation, you need this stuff to occur for this to actually form. Okay, therefore you need heat. Now why can a tropical cyclone not start at the equator itself? Why does it not start at the equator itself? What's missing? Something's missing at the equator.
So there's no Coriolis force.
Exactly, there's no Coriolis force. Why does it need Coriolis force? It has to do what? Good. What is Coriolis force?
The deflection
The movement and deflection of wind. Now, okay, that is important to know. Remember, especially in geography, the most important thing in geography is concepts. If you understand the concepts, you can apply them. Okay, if you don't understand the concepts, you can't apply them. So, when you now look at this thing, so tropical cyclones in essence are intense, rotating, low pressure systems. Why specifically a low pressure system? Specifically, why a low pressure system? Yes, and?
So doesn't it need the instability to form to...
Exactly, because with a high pressure, which you also call a what? Anticyclone, it's a stable condition. You need the unstable conditions for cloud formation to occur, precipitation and all of that stuff. Okay? So we have a low pressure system to be able to have these winds and the rain and the clouds and all of this stuff. Okay? This cannot form in an anticyclone. It can only form in a cyclone, being your low pressure system. Then you have specifically over warm tropical oceans, and as you said, between 5 to 30 degrees, both north and south, right? But not at the equator itself because of that lack of Coriolis force, which you do need. Size varies, and it's important. This thing can be massive. That's why it can cause so much damage. It ranges anywhere between 200 to 2,000 kilometers. That's a massive system, right? So you can see this thing is far more destructive than your typical mid-latitude cyclone. Then it produces strong winds and heavy rainfall, like extreme torrential rainfall. So torrential rainfall means like the most extreme and hard rainfall you can possibly get is this torrential rainfall that is caused by a tropical cyclone. Like this is what causes your floods. It can cause a lot of damage. Too much water can break dams and stuff, you know. So this is heavy rainfall. It's torrential rainfall. And as I said, immense flooding. So not only do the winds cause damage, but now it brings floods as well. And then with floods, you know, with water rising, and it takes a while for this water to then now, you know, recede, all sorts of diseases and stuff can also now be there, right? So you see how many hazards there is to just one of these things actually hitting and causing the mass amount of damage that it can.
The first hurricane of the season will have a name starting with A, the second with a B, the third with a C, and so on.
Okay? So that's important to note. Remember, we name these things alphabetically in terms of how many of them have occurred up to this point. So if it were, for example, Hurricane Gary, how many have there been? If it's Hurricane Gabby, 7, okay? So it's your 7th tropical cyclone or hurricane or whirly. I told you, I love this name the most, the whirly. Australia has given it the coolest name, I think. But it's all the same thing. Hurricane, typhoon, cyclone, all of this stuff is the same thing under a different name. We just name it differently around the world. We call it a tropical cyclone. They just give it these different names and we name it all alphabetically. It doesn't matter like where it hits, it's the same thing, it causes the same damage. We just rarely get it, but we do get it now. Okay? I mean, just in last year we had what, 2 or 3? Especially Joburg side, no? That we had there. So, the locations are tropical cyclone now. We've mentioned it, but repetition is the best way to learn, right? So, warm water generates the formation of these tropical cyclones. Ocean temperatures. Now, what I've noticed, and I would like you all to please be aware of this, especially, okay? Please be aware, especially of the fact, some study guides will tell you 26 degrees and upwards, okay? So, as a result of this, obviously, we will mark 26 degrees and upwards. As long as you are able to specifically tell us it needs heat, it needs latent heat specifically because of X, Y, Z. Understand? This geography, again, be very specific. You can't give one-word answers. You can't say yes. That does not exist. You must specify. Okay? Be detailed. So, one thing also to remember with geography, it's a science, right? As it is a science, it means you have to be scientific in the way you answer, nah? Because this encompasses everything, if you think about it. Stuff that is done in grade 8 and 9 is repeated in grade 10, for example, and so forth. So be very, very specific when you answer. So, ocean temperature between 5 or 30. As I said again, study guides, textbooks differ. They do differ. As long as you can say in the tropics, where it is warm. Okay? Make it a part of it. Obviously, you're not just going to say, no, you're going to say north and south of the equator, right? Coriolis effect is greatly reduced at the equator and lacking, so it doesn't form there. So no tropical cyclones occur there. Again, remember that. No Coriolis effect equals no cyclones. Okay? Interesting question though. We need this for a tropical cyclone, these Coriolis effects. Do we need it for a mid-latitude? No. It's completely different, right? Though both are cyclones, this one differs in the sense of this one is extremely destructive. And it needs specifically the rotation of the Coriolis, right? So, let's look at the formative stage. So you've got your first stage, right? You can see Pressure here, still above 1,000 hectopascal. Okay? So this is still your formative stage. So it hasn't dropped below the 1,000 yet. Okay? So it's still forming. It's still in its infancy as it is here. Okay? So this is now specifically the southern hemisphere. Which way does it rotate in the southern hemisphere? Clockwise, right? So northern hemisphere would then be anti-clockwise. Okay? Just for interest's sake. The odds of them asking about the northern hemisphere is slim, but knowing it is to their advantage, if they do ask this. Then you now get to the developing stage. Now you see from above 1,000 hectopascal, you start seeing this drop. Okay? There has to be a drop in the pressure, so it has to start becoming a low pressure system for it to be a cyclone and for this development to now start occurring. Okay? It starts dropping. Then, also to remember, so if we're formative, developing, in its developing, it's still just a tropical storm, right? We still just know this as a tropical storm, and that is it. But the moment it becomes mature, now it is a tropical cyclone. When do we give it a name? In which one of these two stages? Do we name it when it's a storm, or do we only name it when it's a cyclone? When it's a storm. We already name it when it's a storm. Okay. So we already give it the name of Eileen, Eloise, whatever it may be, determining the number, already when it's a storm. Okay? Then it becomes a cyclone. Now, remember again, many of these cyclones never reach this stage. They will never reach the third stage. They will dissipate or degenerate, whatever you want to say, they'll disappear before they reach this stage. Very few of them reach this stage. Okay? When do they die out? What causes them to die out?
When they move over land.
When they move over land. Why?
Because there's no heat.
No latent heat. So, the moment there's this lack of latent heat, there's nothing feeding it anymore. There's nothing energizing it, giving it that heat. It'll die. Immediately. It starts dying. So, the moment this thing hits, regardless of the destruction it's going to cause, as soon as it hits land, it starts dying. Okay? The moment it hits land, it starts dying off. So that's your dissipation stage. So it's interesting to note the similarities between your formative and your dissipation stage. Both, they again increase about 1,000 hectopascal. Okay. So the low pressure system dissipates entirely. So the clouds break away. That eye wall, that cloud wall thing that has formed, dissipates, it disappears. So this entire system, you can literally see the clouds pull away, break away, and then becoming this degenerated tropical cyclone. Okay. Let's look at it a bit more in depth. So your very first stage, okay, in this, you have your surface conversions and heating, which causes moist air to rise. Right? You need that moist air to rise. Identified by the low pressure on the surface, then there's this growth of tall vertical clouds that start. Okay? Because they will eventually form what is known as that eye wall, which I typically call a cloud wall, but eye wall. Okay? If you use a geographically correct term, it's a eye wall. Okay? I just like calling it a cloud because that's what it is. It's a wall of clouds, right? Okay? Growth of them, then you have this clockwise movement around the center of the uplift. Now, an interesting question linking to this, okay? In terms of the way winds blow from the different pressure systems, do winds blow from a low pressure to a high pressure or from a high pressure to a low pressure? High pressure to low pressure. It blows from a high pressure to a low pressure. Okay? Now it's just something, if they do ask you how it blows, winds blow from a high pressure to a low pressure system. Okay? So typically, we're not as concerned about the high pressure now, just you need to understand how these movements work. Also, do these things move east to west or west to east in our hemisphere? East to west. Remember, they form on that side of our country, the eastern side. There, past Mozambique, Madagascar, that side, okay? Because also that's where we have the warm Mozambique to energize it, okay? So, there's your first, your formative, or you will notice there's sometimes 2, 3, 4 different names for the same thing, okay? So, your formative or initial stage is stage 1, okay? Same thing, different names. Your mature stage, as you have here, so now, in our hemisphere, already as a tropical storm, or as a tropical cyclone now here, within the mature stage, they have in the left-hand quadrant here, the worst weather. For our specific hemisphere, the worst weather occurs here. This is the strongest part of the tropical cyclone. There's the left-hand quadrant. In the northern hemisphere, it's the right-hand side. So, if this portion hits, this portion will ripple through and swing cars and cause damage and cause death and there. Okay? So, 2 important mechanisms operating in this. So, we have a convergence and a vortex. So, warm, moist air converges at the surface. What does it mean when air converges? What happens? It comes together, right? If it diverges? When does the air diverge? Which stage does it diverge here? The dissipating stage. Okay. So, uplift, condensation, the release of latent heat occurs. Remember, the feeding mechanism. See that as like the feeding mechanism. If this thing doesn't get the food from this latent heat, with an empty tummy, if I can use that metaphor, thing isn't going to live, right? So it's definitely a guy who we need food in our stomach, otherwise we do not operate, isn't it? See, I'm saying it needs that latent heat, it needs that food. Where is warming and rising? Okay, it's warmer than its surroundings, so typical, low pressure system, cyclone, it's unstable. Okay, that's the conditions needed for rain formation, condensation, all of that. Air flows around the center of the low, and then a vortex.
The hurricane is at its first stages, where the forward movement of the hurricane is combined with its spinning motion.
Alright, so, should I play that again?
The hurricane is at its first stages, where the forward movement of the hurricane is combined with its spinning motion.
So, that's what makes it so dangerous. Remember, this thing is moving forward and spinning. So it's like 2 forces in one hitting. So imagine you are basically being hit in the front and on the side. Pretty much that's the effect of this thing. Okay? It'll take you out, right? It'll cause damage. That's why this quadrant especially is so damaged. Okay? So the rotational velocity and forward movement combined in this left-hand side, this is what causes the extreme and severe weather conditions. Okay? It's this specific quadrant. And look at this. Your diameter is now plus minus 500 kilometers. Do you have any idea how massive 500 kilometers is? Okay, just get an idea. That's almost basically from here to Durban. That's the size of this thing, huh? Almost. So it's just about 200-300 km further. But that's giving you the size.
So does the hurricane and the tornado share the same effect?
Hurricane and tornado are pretty much the same thing. So they do share the same effect, yes. They do share the same effect. Okay. Then you also see wind speeds of up to, imagine this, 300 kilometers an hour. 300. Okay? We're used to give you the idea so you can sort of understand, we're used to like 15 to 25 k's an hour wind. Okay? If it's extreme, it gets to like 30. Now you've got that multiplied by 10, and you've got a tropical cyclone. This ain't going to be nice. It ain't going to be friendly, huh? And then, as I said, the worst quadrant is here. Your front left quadrant is going to be where you find the worst weather. Then you've got your dissipation or decaying stage or degenerating stage. 3 different names for the same thing. Okay? You can use the names interchangeably because it's the same thing. be aware, since you can use it interchangeably, those set new papers are going to do the same thing. So you might write, for example, now in January a paper that uses dissipation stage. Come June, they might say degeneration stage. Come prelim, you hear what I'm saying? It's the same thing. Just be aware of what are the core characteristics of certain stages and follow with those stages. Okay. So in your decaying stage, so now what happens is the cyclone now begins to cool down as it now reaches cooler latitudes. The moment it hits land, this is when this starts occurring. This is the moment this now starts cooling down. It starts losing that latent heat, so it starts losing its energy. So it basically immediately, the moment it hits land, it starts dying because it no longer has the thing to feed. Okay? But, and here's the interesting thing with this thing, it can resurrect itself. It can regenerate. Because it can, for example, remember I'm not an artist, so I'll try. It can, let's say there's land, again, not an artist. So now this thing comes, there's its path, it hits land. So here now it starts with this decaying stage. But it swings back to the ocean side, so it starts being fed with latent heat again. What happens? This thing gets new life again. It regenerates. So it can then go back to its mature stage. And it can then be very harmful again. Okay? So it can regenerate. From this, it can, if it goes back and it gets fed with latent heat, it can regenerate. That is possible.
What pulls it there?
Rotation forces.
So how often does it happen?
Rarely, but it can. I think Cyclone Freddy was one of those rare occurrences where it actually did turn back. Yeah. But it's rare, but it can. It's just good, you need to know that these things can regenerate. It is quite possible that these things can regenerate. But now you'll also see less warm moist air is now fed into the system. Okay? Dissipation occurs as a cyclone strikes land. Friction reduces the system. No more moisture is fed into the storm. It dissipates. So all of these say the exact same thing. If it hit land, it dies. Okay? That's the simplest way to explain this. The moment this thing hits land, it's bye-bye. It's done. It's over. Okay? So now, looking at your typical, just erase this part. So, looking at your typical cross-section here of a tropical cyclone, do you see how massive this system is? So remember, you've got cumulonimbus clouds here, right? They form the eyewall. But extending from the eyewall, you can have altostratus, cirrostratus clouds here, okay? And they can even extend from here up to 500 km. Okay. So you can see, like on the side, you've got a massive load of clouds, okay? And then in this left-hand quadrant here is where you're going to have the most damage as well. Again, whereas in the eye of the storm, you know, here where you have this diverging, descending air, it's calm. There's nothing happening, but again, don't think you're going to storm chase and get into the eye. That is just a movie. Okay, good luck getting through this. See, it's going to be a bit tough, right? So divergence in the upper part of the storm. So here, in the upper part, you start seeing this divergence, right? Okay, but you also keep seeing latent heat being fed into it, as long as it's over the ocean. So as soon as this also stops, then it also starts divergence from the bottom with this decaying stage. So more air comes out, more air can move into the surface, some air sinks to the center, where air is sinking, stable conditions exist, specifically here. And we know that, geographically speaking, where there are stable conditions, what cannot exist? Rain. Rain, clouds, precipitation. So that's why it's calm here. Because of that descension and the fact that these conditions create a stable condition, The eye is calm. That's why when they speak of the eye of the eye of the storm is always calm, always settled, always quite relaxed, because nothing can occur in the eye. Okay. The rest outside there is another story. And as the air sinks, it is compressed and heated, so that then adds further energy to the storm. So, looking at it this way, so the eye is clear, calm, is the center of the storm. Cool air descends into it, and you have this eye wall. So, not only is the eye wall thick, but it can be like 15 kilometers high. Huh? Imagine you're looking at something 15 kilometers high. That's higher than any of the roofs here, by the way. This is like almost skyscraper. You're seeing what? I think it's like 8 stories, more or less. You know, an 8-story building. Imagine an 8-story tall storm. I wouldn't want to see it, but you hear what I'm saying. It's going to be rough. Cool air descends, you've got the eye wall, clouds extending. Now look at this, 500 kilometers either side. Okay, remember this thing can be anywhere between 200 to 2,000 k's. Okay, this thing is massive. You are going to see it. It's not like you're going to miss it. You're going to see it. Do you understand why this thing causes so much damage when it hits a specific city? I mean, it's almost as wide as the city itself. Okay, even though it starts dying up, all that force and that left quadrant, all of that is still active when it hits and moves in. Okay, so it can still cause that damage. Pressure drops, wind speeds, hurricane strength, about 117 k's an hour, up to 300 k's an hour. Okay, mature stage can last, even though it starts, last up to 7 days. And heavy rainfall. 7-day storm.
It takes that long to disappear.
I don't know why this is not working. Okay. Anyway.
At the eye of a hurricane, wind and pressure drop suddenly. Calm and clear conditions are experienced with the passage of the eye. This condition lasts for 30 to 60 minutes and covers an area of plus minus 13 kilometers in diameter.
Okay, so look at this. You've got your warm, moist air spiraling towards the center of this hurricane or tornado or tropical cyclone, whatever. We'll just call it a tropical cyclone. You've got the convergence of the air coming together with the air forcing it to rise. As it rises, moisture condenses out, okay, warming air and allowing it to continue to rise, and it causes even lower pressure at the surface. Okay. And then as it decreases, winds intensify, and more warm moist air is then forced to converge and rise. So you see how everything is basically pushed up in this. Okay. All this warm moist air is being pushed up, and that causes this nice cloud formation and condensation, everything in to occur. Pretty much, this is what the system will look like when it's active. Okay. Now, you've seen they speak of it's a category 1 storm, or a category 5 storm, or a category 4 storm. Last year, for the first time, like in history, they called a tornado a category 6 storm. Never had that till last year. There is no category 6. I think it was Texas. But there is no such thing as category 6. But history is made. So, this is all categorized according to your wind speeds. Okay, your miles per hour there you can see. Your pressure, and then your tropical depressions, storms, hurricanes. Okay? So your category 5 is going to be your worst storm. If this thing hits, That is death, destruction, disaster. This will be a disaster when it hits. If a category 5 hits wherever, it is a disaster. Okay? It's as simple as that. There will be a great, great disaster.
So how come the pressure is less in category 5?
Because the lower the pressure, the more air was forced up, the bigger the system can be, the more unstable conditions exist. Remember, you need extremely unstable conditions and an extremely low pressure for this thing to really build out and build up to cause that damage. Okay. So, further characteristics. If we look at it like in terms of a map, so that it makes a bit more sense. You've got your first stage here, so your formative or your initial stage. So you see fallout. It starts occurring here in the tropics, right? Your 5 to your 25 or your 30. It starts, developing. Then it moves from east to west. So that is also important, again, to bear in mind. East to west for the southern hemisphere. Okay? Then it starts moving away from the equator. Okay? So you start seeing this turn. As it starts moving, you start seeing this turn away from the equator. To which country? Madagascar, right? Then you see there's an eye, but there's no wind, rain, or clouds yet. Okay? Remember, as it starts moving. So, now it starts hitting and it starts causing destruction. Storm winds, torrential flooding, torrential rain, all of that. Okay? Then it turns east at 30 degrees. And then it disappears. No moisture, no warm air friction. To give you an idea of these characteristics. So they will form on their path and they will basically die out. Many of them, as I said, never will go past that stage. They'll die out before that. So they're not even care about it. So weather associated with this is, first of all, torrential rain. Remember that there are, three types of rain: convectional, orographic, torrential rain, right? That you need to know. Torrential rain being one. So imagine in one day, 3,000 millimeters of rain. What happens when it rains too much? Soil becomes saturated. It no longer drains away. So you get this rise in water. Okay? Increased runoff into rivers, wetlands and dams, and then you have this risk of flooding. And flooding in itself can also break buildings and damage cars and everything, right? Then you also have storm surges. So they occur when the tropical cyclones reach land. A storm surge is a large wave. It's a massive wave. It's not a tsunami. Okay? Remember, tsunamis are caused by what? Do you still remember? What causes a tsunami? Do you remember?
No.
This is what? Grade 11's work. What causes a tsunami?
I never got something.
So there's a rising winds.
I'm shaking my arms. You're looking at me. Earthquakes. Okay. So this ended, but it caused waves that are extremely large. Now, large waves, similar to this tsunami, will cause damage, right? So that's a storm surge. These things are like 6 meters high, okay? They're higher than normal tides, created by heavy winds, and they, in and of themselves, cause flooding. Okay? So you don't want to be near coastal areas during this time. Now, a very important question. As I said, this question can be phrased in different ways, okay? It could be in multiple choice questions, it could be as a 4-mark question, it could be as the paragraph question. Okay? There's multiple different ways they can ask this specifically, but they will ask you how this can be managed or mitigated or whatever terminology they may use. You need to understand, how do you manage and mitigate a tropical cyclone? Okay, so visually speaking, if you look at this now, you have an air radar and remote sensing, first and foremost. What is remote sensing again? Satellites. You follow this thing on satellite images. GIS, the Weather Bureau, these people, right? They will work specifically with these satellite images to get the picture and to be able to warn people. A land radar, proximity. Huh? You want to determine how close is this thing to striking, because you want to evacuate people. Okay. Are you going to leave people with a tropical cyclone? Then you want to evacuate. So you want to have like buses and whatever you need ready to get these people away. It's important to mention that. It's cool you have the equipment. And then, what's the use of you having the equipment if you don't have stuff to do stuff? You know what I'm saying? You specifically. Okay, so this is now like just an example from Texas. So then, storm warning patrols, you've got evacuation routes, evacuation centers, so shelters, very important. Good communication, areas, and buildings that have been flood-proofed. It's no use you move away the people to a place that can flood, or to a place where they can still get, the consequences of that specific storm. Housing on stilts might be a good idea. Seawalls. Okay, so these seawalls are meant to break the waves that arise, to mitigate the damage that occurs. If you go down to like our west coast and stuff, there's those funny shaped, blocky type things. They look, like that game you can play, the spiky stuff. They look like that. Same thing, they are wave breaks. They're meant to mitigate damage from waves so that less flooding and less damage occurs. Okay? Emergency rescue services, obviously, can you do this without having ER standby? No. Okay? Extensive medical and paramedic provision. You need the doctors and stuff. People are going to get injured because if people panic, what do? They run, they trample, they do not care what happens to other people, right? It causes a lot of issues. Okay? So these are things you need to bear in mind and keep in mind to mitigate. Now, these are just some examples. You can obviously think of your own to add of things. What would you do to help you? Okay? Then preparing for the worst. Okay? Let's have a look at this. Okay? Precautions that can be taken when there is a warning. Avoid crossing strongly flowing rivers. I think that makes a lot of sense. I think even with this, move away from, where people build their houses next to rivers. Move away like immediately. If there's a warning, you should be the first to pack up and go. Dwellers, evacuate. Farmers should move pumps away from rivers. Okay? Otherwise, more damage to property, further issues. Small, medium-sized fishing boats should return. Boats should be moved away. Listen to the radio and television, and listen to the advice of the local risk management officials. So, whoever are the wardens and the people in charge of handling a specific situation, they're the ones to listen to and speak to. Okay. Now let's look at specifically our country. Where did they occur? Summer. The peak period are these 2 months, January and February. This is the peak period, okay? So, note, when do mid-latitude cyclones occur? Winter. So, summer we have tropical cyclones. Okay. And remember that they also move in different directions. Okay. We have a mid-latitude moves from west to east, tropical from east to west. Also in different seasons. Okay. So you can almost say they complement each other. When the one has left, the other comes back. Okay. So, only cyclones that move along the Mozambique Channel are likely to influence our weather patterns. Why specifically the Mozambique? It has what?
Yes.
Because it's a warm Mozambique, right? Can it work on the cold big weather? And then if I ask you what the other name for the warm Mozambique, what is it also called? What is the other name for the warm Mozambique? A gallus. A gallus. Okay? They can use the term gallus. Let me just write here. So a gallus. They can use the term gallus. Okay? They can ask you specifically about that. Now, many reach Madagascar first when the intensity is reduced as they then move. Many dissipate before reaching the coast. Remember, many never reach the mature stage. They die out before that. Okay. So, impact, they're a threat to human life, property, and even economic activities. In the sense of, if you think about it, this thing can ruin farmland, right? It can ruin a business, so it can definitely have an impact on any economic activities. Okay? It can. Whatever sector it may be, it can affect all four of the sectors. Okay? Primary, secondary, tertiary, and quaternary can be affected by this. Okay? Especially quaternary because communication line and everything can be destroyed, right? Through this. Okay? As an example, a number of years ago, there was a hurricane called Hurricane Katrina that hit New Orleans, right? And have you ever heard of this? Hurricane Katrina. This is a few years ago that this thing hit. Okay? 2005. Okay? Winds of over 250 kilometers per hour. Okay? The storm surges, the waves, were 8.5 meters high. Okay? So, that's what it looked like after it hit. These are homes, by the way, guys. So, I mean, these people lost their property. And like literally everything inside their home was flooded and gone. Imagine that, you lose everything. Boom. Everything in a single day. Okay? And what was worse is they had not seawalls, but protective breaches to minimize, damage and stuff. This thing completely went over it. You'll see on the one side, it almost looks like there was less damage, but look at this side. It's red. It's red, huh? People that have not left their properties, what happened was, they like climbed on top of their roofs and stuff, waiting to be rescued. They didn't leave, they didn't evacuate, so stuck on a roof. You don't know how long you're going to wait. You might not have water, food, So, this was a hugely devastating natural disaster. So, there is the picture of what it looked like, 2005. 20 years ago. But still today, one of the worst storms ever recorded. Was Hurricane Katrina. Okay? So, flood levels, more than 6 meters. Okay? Typically, like most people are like 1.8 meters tall. So that's like what 3 people in length that this water was high. You can be a good swimmer, but you can't swim all of that, can you? Okay? 80% of the city was flooded. Over 1 million homes did not have electricity anymore. 700 deaths. 1 million people had to leave their homes. And 24 million liters of oil was spilled into the environment. So not only did this thing cause damage, can you imagine the damage to the environment? 24 million liters of oil into the environment. And then over $81 billion worth of damage was done. Multiply 81 billion with what is the dollar now? 24, 25 bucks or something?
18.
But either way, 81 times 18, I don't even try doing the maths, but you can imagine. It's chaos. Okay? It's pure, utter chaos. So, If you look at tropical cyclones in a nutshell, what I mean by looking at it in a nutshell, like let's call this extreme summary, if you will. Names, it's done alphabetically, right? Andrew, Bonnie, Cole, Edward. Origin, in the tropics, over oceans, not nearer than 5 degrees from the equator. Movement, east to west, away from the equator, and then it turns again at 30 degrees. So it makes that turn. So on the path, it basically goes, and it turns. Destruction, storm winds, torrential rainfall, flooding. Where's the strongest sector in this thing? Strongest sector of the storm, yeah.
Eyewall.
The what quadrant?
Oh, the left side.
The left-hand quadrant, right? Okay. In the eye, nothing happens. No wind, no rain, no nothing. Everything is just cool and chill, right? Weather, good. Before eye, during eye, after eye. There's different forms of weather, right? Since this thing moves forward and rotates. Damaging, calm, damaging. Okay? Still going to cause damage as it moves over, and as it has moved over. You're left with that aftermath. Dissipation over land, no moisture, warm air, friction, no latent heat, done. How do you manage it? Sandbags, early warning, satellite, remote sensing, all of that lovely stuff informing people evacuating. So in a nutshell, these are the 8 critical things, literally in a nutshell, for a tropical cyclone. If you can take these 8 aspects and you know how to elaborate on each of them properly, you can answer any question. I mean, what question can I ask you that you cannot answer if you know this? Does tropical cyclones make a bit more sense?
Yes.
Will you now do better on tests when I give you a test again? Obviously you didn't do badly today, but you see that there's minor details you missed. Okay. This all is on your teams. You can download this. Mid-latitude also. I'll do a revision of mid-latitude, I think, then next week. Along with then, what is the other one? The subtropical anticyclone. Okay? Obviously now in this week we're going to start your urban and valley climates as well. There you'll see some of the stuff. There will be new urban heat islands, adiabatic winds, katabatic winds, the different times of day they occur, the different heats. Okay? But again, I'll try to summarize it in a nutshell so it makes more sense. Okay? If you can take this, literally, what can I ask you that you can't answer? Okay, maybe, okay, not all the stages might be in here, because I have formative, I have mature, and I have dissipation. So 3 of the stages are there, right? But the only thing I don't have is where it's a tropical storm, the second stage. But I have cyclone, I have dissipation, and I have formative. Okay. So, either way, just knowing that, you will know the 4 stages. Whereas in mid-latitude is? So that's 4. Okay. So, that's 9 stages you need to remember. 5 for mid-latitude, 4 for tropical cyclone. Can I give a hint? Remember guys, this is geography. You see me regularly take up something and draw, even though I can't draw to save my life. Okay? If it helps you to draw, you're not going to lose marks if you draw a picture. But explain. Remember, you can't just have a picture and then what? But if it's going to help you and you're like stuck in the vine and you start drawing, there's clouds and there's wind and there's whatever. You see what I'm getting at? Is it going to jog your memory a bit? You're allowed to draw your geographers. I had a professor at university tell me to draw. University. So why not? Draw. if it's going to help you draw the stuff, but explain it. Okay? Still bear in mind you've got limited time, but rather than you sitting there and wasting half an hour staring at a paper, draw and tell me what you're drawing and move on. Or answer the rest and come back. Okay? Bear in mind as well, when it comes to answering a geography paper, okay? And I told you the same thing if I teach you English as well. Just because it says question 1, 2, 3, doesn't mean you have to start with question 1. If it's going to be easier for you in paper 1 to answer GMorph, answer all of GMorph. Answer all of map work and do climate last. Okay? It doesn't necessarily have to be in order, because what happens at the marking center at the end of the year, they assign you questions. So I might mark climate, another teacher might be assigned GMorph, another one map. But then you mark like in groups, no? You mark like that question, and then it gets passed on to the rest and moderated and all of that stuff. So the order doesn't matter. We have to mark your question anyway. You hear what I'm saying? You don't have to do this stuff in order. Do where you know you'll hit the most marks and go back, instead of wasting time. You've got 3 hours. 3 hours sounds like a lot now, until you write geography. Then you realize it's not as much now. It's really not as much. Other advice I like to give, okay, especially in geo, be like the last to finish. Don't rush yourself. Use your time wisely and use the 3 hours. Okay? You're not going to get a medal or win a marathon by finishing the quickest. Take your time and do it properly. Okay? Do it properly, do it precisely, and you know you score the best marks. Because I can tell you now, paper 2 is easier, usually. Paper 1, climate GMorph map work. Paper 1 is a doozy, huh? But it's possible to achieve your 80 if you know the concepts, you know how to apply them, and something like this. Okay? And also remember, any subject you get 10 minutes reading time before you write. Please use 10 minutes reading time and go and read the case studies. The reason I'm saying go read the case studies is now you guys want to read the multiple choice and start answering in your head. Then you get stressed when you get back there and you can't remember what you answer in your head now. Am I wrong or right? So forget the multiple choice until you start writing. Read the case study. Get an idea of what you're working with. Because you will not get both cyclones in one test. You won't. You'll get tropical, you'll get maybe adiabatic winds, you'll get maybe the urban. You hear what I'm saying? You'll get a cyclone. Odds of you getting both? Very similar. Maybe in your test term 1 you might get both, but the odds are still slim. Okay. I hope this helped. Truly hope you will do well with tropical cyclones now. Okay. Then have an awesome day. Thank you.